Alright, so here we are taking a look at the ISAT QR1 D series. Now, we're going to take a look at the first two scenarios that are currently available in this series set and see some of the key things that apply to them. But the third scenario, as of the recording of this video, has not actually been refined or uploaded yet, so you may be taking some of these ideas and applying them in a new and unique way for the third one, and we will not see anything directly key to the third one in this video, although some of the things that we introduce might prove useful. Okay, jumping in. The two that we are going to take a look at least briefly, not giving you too much information on how to go about maximizing your orbit or anything like that, but showing you some of the key tools that we want to make certain that we've got to make analysis easy. The first one that we've got is 1D1, the scenario pilot, not pirate, radio. And this one introduces that we are trying to set up a satellite streaming service, and we are setting that up to try and deliver music to both LA and New York City, basically targets in North America. But we have a hostile actor down here in the South Indian Ocean, or this might be the Pacific. It's near Indonesia, anyway. We've got a pirate ship out there that is standing guard, probably to try and take advantage of local shipping as well. So I wanted something that was a bit away from the United States. So I chose a spot over there that has at least some pirate activity for the nature of this scenario. Okay, our goal is this. We want good contact times with LA and New York so that we can deliver a lot of content to them. However, this is one of the first times that we're going to take a look at, and we don't actually care about the total time that you contact the pirates. We only care about how much time you're in contact for any one given contact. The idea is, when the pirate ship is able to see the satellite, they can try and connect to it and maybe try and hack into the satellite. But that's going to take some time. And that's the idea behind our scenario, where we go down and we have what the IT firm that we've hired to try and secure our satellite says is every time we complete an orbit, we can quote-unquote update the security settings on the satellite and basically force the pirates to go back to square one to try and go through and actually hack our satellite. So every complete orbit, we say that everything starts over. There is no risk if there's very little time of contact between the pirate ship and the satellite. There's low risk if we have, let's see, there is a low risk to the satellite for contacts equal to or greater than 20 minutes. Okay, so if they have line of sight on our satellite for 20 minutes or so, then or more, then there's a small chance. It's possible they could hack the satellite, but not very likely. But as those time in durations increase, we go up to moderate risk. So any contact that lasts for 30 minutes or longer, it's much more likely that the pirates will be able to hack the satellite. And furthermore, IT is convinced that basically 40 minutes is the line. If they're in contact for 40 minutes or greater, then they pretty much are guaranteed to be able to hack our satellite. And that's the idea that we have behind this scenario, trying to connect it to something that might be sensible or might reflect real life. But our goal is, in this particular scenario, is to get you focused not just on the total number of minutes, but in this case, the duration of any individual contact. It doesn't matter if the pirate ship has contact with the satellite for a total of 7 days out of an 8-day period, so long as any of their individual contacts are lower than the threshold of 40 minutes. Now, in the scoring, if you have even one contact that is 40 minutes or greater, then you would end up with a score of 0, because most likely you've just lost the satellite to some pirates. But there are points based on how many low risk and moderate risk contacts there are. For every time that there's a risk involved, the more of those risks would pile up to be not as good of a solution. And that's represented in our scoring. I'm not going to go through and talk about the finer points of the scoring, but I want to introduce the mentality, the thinking that we have for this scenario so that we can look at the things that we need in STK. So going back over to STK. Let's see. For this, we're going to need to bring up information. In particular, while we do want, say for instance, the contact time between New York City and ISAT, I can do compute reports. I can bring this up and look at it. And then, like usual, we are looking for the total time for New York City and LA. That's something we've seen plenty of times before. But something that's new is this other thing that we're looking for. Okay, first off, I'm going to remove all. Just as a heads up on this, I'm not seeing all of my window here, and there's a bunch of dead space in my timeline. Some students like to get rid of the timeline altogether. In this case, I'm not quite going to get rid of it, but if you come up here and hover on the edge, you'll see your cursor will turn into an up and down arrow. If you grab there and then slide down, you can actually squish this thing down a lot more. That may have been a little too much. I do sometimes, as we will see, like to use the timeline down here, but I do also really like to have the extra screen space. I'm going to click close. You can close this if you want. You can reopen it by going up to some of the windows up here to re-add the timeline view. But keeping with this, one thing that we really care about is the contact between ISAT and the pirate ship, the Pirata. So I'm going to bring this up. I've now computed it, and I've got my access. Now, one thing that I'm going to bring up is this. I mentioned the timeline. Here's a reason that might be good to keep it around, because now we can actually see there's a little blue line here for every time our satellite has contact with the pirate ship. And that line will actually turn into a wider, like, bar, depending on how long those contacts are. We can also see that we've got a bunch of contacts kind of back in one right after another, like clockwork, and then a large dark period. Anyway, those are some things that you can get from the timeline and are useful information depending on what you're looking to do. But over here, I would say the most useful thing for us is actually going to be the report, and we can go through and we can look at our duration. Now, I could go through and first off, scroll all the way down through almost 130 contacts that we have during this time period, and I can look manually for a value of 40 minutes. But I can also go to the very bottom and see what my maximum duration is. Well, the biggest number in this list is the max duration, which is 13.635 minutes. Okay, I'm nowhere near losing my satellite with this orbit. Though this is the default orbit, I haven't bothered changing anything, and I probably won't for this particular lesson. But I do want to point out that I'm probably not getting a whole lot of points on this either. We're going to go through and show how you can work with this in spreadsheets as well. And when I do that, I'll probably say I want to use this particular export to work with because I don't want to solve the scenario for you all. And we may go through and we might change it from, say, 20 minutes and 30 minutes down to maybe 10 minutes and 15 minutes. So in this case, let's say for the sake of argument, because I don't want to solve the scenario for you, but I want to show you the tools involved, let's say that our low risk was anything greater than 10 minutes and our high risk, or our moderate risk, was anything greater than 15 minutes. Well, in this case, I could tell pretty quickly that all I have are low-risk instances, but out of 130 contacts, some of them are low risk. So we've got here 1, 2, 3, 4, 5, 6. I'm going to stop counting here because you can get an idea of how long it's going to take for you to manually count all of the instances of being greater than 10 minutes are up. And that can get even harder when it isn't just a nice 10 minutes, because it draws my eye to see, okay, if there isn't a number here on the left-hand side, and there's a little indent, then those are the ones that are indented, don't have a 1 there, I can ignore, and then I could count all the ones. But when you switch to 20 and 30 minutes, you don't have the clear indicator of that indent. You kind of have to look closer at the number. Okay, so one of the first things that I want to emphasize on this is it would be awesome if we could work with this set of numbers independent of STK. Now, you may be able to go into the custom reports in Graph Manager and set up a report that does a lot of these things through STK, although I'll be completely honest, I haven't developed all those skills myself, though I add to them when I can. What I'd recommend is being able to work with a spreadsheet, say Excel or Google Sheets. Part of that is, okay, if you can do it in STK, that's wonderful and it saves you a step maybe, but then you only know how to do it in STK. Whereas if you know how to do these things in Excel or spreadsheets, then that'll carry over to all sorts of things, not just STK. In fact, that brings us to one of the key things that we're going to introduce for this series. This series is going to have you starting to work with the individual numbers and caring about possibly each individual number. In order to work with that, instead of being able to just rely on a summation or a total down here at the bottom, we need to get these numbers somewhere where we can work with them. And that's the first of the key things I want to show you in this STK video. Now up here we can save as text, or the next one over actually has a picture of an old school disk, that's the save part, and then in the background it's got a green X, which is actually a reference to Excel. In this case, if you hover over it, it says save as .csv. Now we've got a lesson in our spreadsheet skills about CSVs. That is a comma separated values file. That's the CSV. And these are so common. Almost every program that I've worked with that deals with numbers allows you to export those numbers as a CSV. Including in my physics classes, we actually have some of our smart equipment can collect a whole bunch of data and then export it as a CSV. So I'm going to click on this button, and you'll have to find it. It's going to try and create a file, a comma separated value file, .cvs, and it gives it a default name that describes the name of this report. Well, this is satellite ISAT to facility Pirata, and it's the access report. I usually just leave the default name. One thing that you'll want to do is, a lot of times it will default, when this comes up, it'll try and put it in a folder that's related to STK. I like to keep all of my files in a common place, as we've mentioned before, in case you need to find them or delete them by the appropriate time. So what I've done is on my desktop, I've set up a folder for ISAT 1D1, the scenario that I'm working. And so I can put all of my files in there, and you can see that's where I've already set this up to export it. Normally this would be completely blank and I would just click save and it would put it there. This time it's going to yell at me and say, hey, this already exists. Do you want to override it? And I will say yes. Okay, it sends me a warning that says files containing dates, which is what we've got here, must be imported into Excel using a specific process. Basically, it's warning me to use these numbers sometimes takes a few extra clicks. Head over to our spreadsheet skills section or watch the video associated with this for the sheets lesson to know how to do those things. On this, it'll say it every time. You'll get tired of it. So I'm just going to click Don't Show Me This Again so that I don't have to see that error every single time. Okay, so that's exporting the CSV. In the other lesson attached to the D series, the Sheets one, I will show you how to import that into Google Sheets and/or Excel so that you can do some work with it. Next up, the next thing on my list that I wanted to work with was constraints. Now, for that, that's something that doesn't necessarily show up in this scenario, which is the pirate situation, but we do have, let me double check, yeah, I don't have any constraints listed on this. But when we switch over to the second scenario, the Jovian jaunt, we introduce some new ideas. Now, we've already talked a little bit about constraints before in one of our previous lessons, but I do want to bring it back up and show an interesting sensor that we've set up for the Jovian jaunt. There's another thing that I'm going to pause and take a look at real quick. In order to load this scenario, when you install STK, you must have the planetary data supplement. Name something like that. I may be misordering the words there, but it allows you to have central objects other than the Earth. Has a bunch of additional information and allows us to go to, in this case, the Jovian system, which is a fancy term for Jupiter, being around Jupiter, and some of its moons. There's Europa, there's Io, there's the Sun, and there's Jupiter in the background. This is a Jovian moon, a moon of Jupiter, called Ganymede. Now, Ganymede is fascinating. Read the mission brief to learn more about it, but it's an incredibly important place in our solar system. We've got a number of satellites that are set up in orbit that we're trying to avoid, a lot like the pirate ship. We're also trying to contact something on the ground, much like New York and LA, but this time everything is moving, because the thing that we're trying to contact on the ground site, or on the ground, is actually, it looks like a truck in the 2D view. I can zoom in here, the OPA. And that's actually a vehicle that is making its way across the lunar surface of Ganymede from one location to another. We're trying to contact that, but we're trying to keep our satellite away from other satellites to avoid problems. So, in order to view this at all, to load this up, you will need the planetary data supplement. If you have it installed and you want to see how you can actually switch from Earth to something else, you can go to, I believe up here on the drop-down. Oh, the drop-down may not have all of these. You may need, View, Planetary Options. So when you're in STK, go up to View, and then make certain that you've checked Planetary Options. If that's not there, you probably don't have the full install that you need, and try and get those missing things. But when you check the planetary options, that allows you to switch around to different central objects. Like we could have done a mission around Jupiter, or around the Sun for that matter, or, in this case, a Jovian moon. Alright, so that's a little bit on the planetary data supplement. Let's talk about the constraints. First off, the COM, which is a sensor that I've programmed in here. Let's see, I'm going to press play. Let's let it go. Let's have ISAT come around, and it should make contact with the vehicle in just a moment. There we go. And we can see that my sensor came into existence and then disappears. Well, the reason that it's done that is I've programmed in the range limitation on it. I'm going to back it up. So we are now within 1,200 kilometers, which is the range of this sensor. So it actually shows it. But the way that I've got this set up, not only do I have the range set up, a constraint, but this is a special sensor that I've set up where it will always try and point at the target if it's able to. So let's see how I set that up. Right-click, go to Properties on my sensor, and I can go down to, first off, Definition. It's still a simple conic with a certain field of view. Pointing. I've switched the pointing type from a fixed down to a targeted. And when I say, okay, this thing is targeted, it's trying to look at something the entire time, I tell it which thing it's trying to target. And I've added over here the OPA. I press the over arrow and I added it to this list. So this sensor is constantly trying to look at the OPA ground vehicle whenever it can. That is one of the things that's new in this scenario. So I wanted to show you how I made that happen. Next up, basic. I have introduced a basic constraint of 12,000 kilometers onto the sensor. So if I move forward here, we can see that I do have contact. Everything's looking good. And then when I get a little bit farther away, when I reach the edge, it disappears. Okay, so I'm going to go a little bit farther. I'm now more than 12,000 kilometers away. Watch what happens when I remove that range limitation. Oh, now the sensor came back, because I've removed the limitation that it's at 12,000 or 1,200 kilometers, not 12,000. And so by removing that, STK goes, oh, well, it can see it, so I'm going to fill in the little thing. If you're having trouble getting contact, you might be just outside the range, so temporarily removing that limitation so you can visualize it might be helpful. But just because you remove it doesn't mean that the grader will take it that way. So you can remove it to get an effect there, but you want to put it back when you're actually doing your analysis. The reason that you could take it away is if you're not getting any signal whatsoever and you can't see anything, sometimes that can be a little confusing. On that note, so now we've talked about the range itself, let's find another way of actually setting that up. In this case, I could try and find the distance, the range, from OPA to the satellite and see if it's 1,200 kilometers or less. Well, I can go and right-click on OPA and do Access, and I could check with the targeting sensor, the COM. So in this, I can pull up the contact report, but I can also, beneath that, I have AER, which is azimuth, elevation, and range. Azimuth is basically north, east, south, west, which direction you would need to point from the ground, looking to try and see where this thing that you're targeting is at. Elevation is basically how high up you look. But the key one that we're going to look at is range of 1,200 kilometers, or actually range in general, but our limit is 1,200 kilometers. And so we can see I never see a number in here that's greater than 1,200. This is a spot where we can actually bring up the range, the distance for my object to something else. In this case, I'm finding the distance between the OPA and the COM sensor. Okay, real quick, let's see where this could become problematic. If you're working this scenario and you take the satellite out to, I don't know, maybe 1,500 kilometers. Yeah, it's going to yell at me. Give me just a moment. Same old, same old. I'm going to bring this up to 1,500 kilometers. Apply. Okay, now that I've got that, I'm going to minimize this, and I'm going to take a look at, once again, compute, and I'm going to look at my access, no access. Range, no range. Well, crud. If you're trying to design an orbit like this, where I've seen myself and some of my students have a hard time, if your reports are all giving you just zeros, you have no idea if you're completely off or if you're really close. So one thing that I'm going to bring up on this is the COM is limited to only 1,200 kilometers, but ISAT is something that it's attached to. So I might be able to get the range between ISAT and the ground vehicle. So I'm going to try that. Compute. Access? No access. Reports? No reports. This can be a useful thing, but I've also set up that ISAT also has a constraint. I mentioned that it would disrupt anything if it's within 1,000 kilometers, so to make that easy for you all, I introduced a basic constraint of it being limited to 1,000 kilometers so that you could pull an easy report to try and find how many times it gets too close to the other satellites. I'm going to remove that for just a moment, and I'm going to take a look back at this. So now we've got this back updated. Compute, access report, we've got a whole bunch of contact times between the satellite and the OPA. We've also got, here's our range report. Well, we can see that our range is 3,000, going down to 2,000, maybe about 1,500, and then it counts back up to 3,000. Basically, we start off far away, and then we get a little bit closer, get to our closest approach, and then end up going back farther away. We can go through and we can find our maximum and minimum for each of these, for each of those values. Oh, yeah. It says elevation, but our range. So the maximum range was 3,185, and the minimum range was 1,500. Well, that's why I'm not getting a signal on my COM, because it's attached to something that both of them are just too far away. So here's a creative way that you can, without removing the limitation on your COM, try and find out how far it is from your target if that thing is tied to another object, say ISAT. Now, unfortunately, I've now removed the other constraint that I wanted to talk about, which was my limitation for the ISAT satellite to see if it's messing with other satellites. I'm going to leave it off for just a minute because right now I want to look at specifically my information between the satellite, and COM for that matter, and the OPA. Okay, now that I've updated that, let's go back in. I can refresh this, and we can see, oh, my reports have gotten much larger. This is from the OPA ground vehicle to the satellite, ISAT, and we can see that we start getting much closer. My closest approach on this is 1,035 kilometers. Yeah, 1,035 kilometers, which means I should get close enough that for a brief period of time, somewhere in here, where here's 1,200, at about, 4 January, 1:58, we come in contact, and then we would leave contact at about 4 January, 2:12. So let's double check if that matches up with what we see. Our first contact, hey, look at that. We come into contact on 4 January, 1:58, and we leave at 2:13, a little after 2:12. We can actually see that in our range report as our satellite gets closer to and then farther away from our target. We leave the 12,000 kilometer range, and that's why our sensor stops returning information and no longer has an access. As I said, being able to turn on and off these constraints, you want the constraints in, especially for the grading, and to find out what's happening with your scenario and interactions between them, and to match it to the real-life challenges that are laid out in the scenario. But when you're working it, sometimes to get numbers to help get you in the ballpark, or to get you things that you need to get a better solution, it might be worthwhile to disable some of those constraints. All right, the last things that I want to bring up on this, so that we can see all the key things that we're looking for. First off, I believe this is the first time in any of my scenarios that we're dealing with a ground vehicle. A ground vehicle is set up to actually drive around or move across the surface. So one of the things that you normally have to define for it is a route. Now I've gone in and I put in the latitude and longitude of the targets that I created on the surface of Ganymede, and then I adjusted their ground speed. I think the default ground speed came up to like 100 kilometers per hour, which is kind of good for highway speeds, I guess, on Earth, but this vehicle is going to be going across rough terrain and is probably a rover of some kind. I actually went through and adjusted the speeds down to about 11 kilometers per hour, which is equivalent to 0.0031 kilometers per second. And I came to that because basically it'll complete its journey right around the end of our scenario that I had set up, from 4 January to 19 January. So it's almost done by the time it actually finishes up. You can insert points and add different locations for the vehicle to travel to. Depending on what you've put in, one of the times I accidentally put in that it was going a very long distance and the speed was set to like super low when I was trying to set this up because I was trying to do it a different way. And then when I clicked OK, STK was calculating stuff for like 20 years into the future. So be careful what you actually click on in this. You might send STK into having to run a bunch of calculations. You're probably not going to have to work with these, but I wanted to show you what this is and where it's at. I don't have any constraints on the OPA vehicle, but I could have easily added some. I thought about including things like elevation angle, to say maybe it's in a crater or by some hills, or azimuth, maybe it's receiver, the part of the rover or vehicle that picks up our signal, maybe it can only point to the front of the vehicle for some reason. So I could limit my azimuth angle. That would tell or put a limitation in which directions in front of or behind the vehicle it could actually pick things up. I didn't do that in this scenario, but I figured I'd mention those in case you're looking to design some scenarios yourself. All right, so that's the ground vehicle, the very last thing that we've got for you. So first off, one of the things that we also care about is our report of contact between COM and OPA. So I'm going to bring that back up. Hopefully I've got all of my constraints put back into this, but I'm going to do my report. Okay, so here's all the contact stuff. Here's the problem. I don't actually care how long each of these durations are. I care about how spaced out they are. And that information isn't available by default on the regular access report. Now, one thing I could do is I could actually export this particular report, save as a CSV. I could see how it comes up on ISAT 1D 2 Jovian Jaunt. I don't even know where that is. I'm going to go to desktop, and I'm going to go to ISAT 1D 2 is what I should be doing, but I'm going to put this here. Don't show me again. So I can export this, and in our Sheets lesson, I will show you how to manually do this. But luckily, this is something that is actually pretty common to be a concern for space-based missions. And so STK, AGI, has automatically actually programmed in the report we're looking for. I'm not looking for the time between when I start contact and end contact. What I want is the time between ending one contact and starting another. Now, we can take this regular access report, export it into a spreadsheet, and then do a little bit of math to actually get the information that we're looking for, which could still be useful for a variety of reasons. But we can also go over and find the gaps report. Okay, now in order to find the gaps report, the easiest way to do it is right-click and go to Access on whatever thing you're looking for the gaps on. That's where I was just a moment ago, but I'm showing you starting from just the main scenario screen. Get your stuff calculated up. I'm calculating between the COM sensor and OPA. And instead of going to Reports, Access, or AER, or even the graphs, go down to Reports and Graph Manager. Now, I got this set up for you by actually opening this before I saved the scenario and closed it out. So under My Favorites, when you load this scenario, it will say Gaps. But if that's not there, you can scroll down and also call out to all of these great pre-made reports that have been put into STK. We've got the gaps report here. When I click on it, it's the same thing that you would get by clicking under the My Favorites, and we get the following. This is doing exactly what I said. It takes the end of one contact and compares it to the beginning of the next one. So while I contact the ground vehicle, and lose contact at 0213 hours, and then my next contact is at 0554. The difference between those two is basically I've been out of contact with the ground vehicle for 3.7 hours. Well, we can see that we've got a pretty regular period here where we've got 3.7 hours, 3.7 hours, give or take. They fluctuate just a little bit as the moon rotates underneath us. And then all of a sudden there's a huge jump. We'll look back at that in just a moment. But every so often, every few orbits, we have a huge jump. Now, the main thing that we're looking for, because you're going to have that jump depending on what orbit you have, and there isn't too much you can do about it depending on your orbital limitations. So this scenario is based around whatever the average, the mean duration of your actual gaps is. So here's where you can get that number quickly and easily. The default number is 9.995 for this particular scenario. Now, when I adjust my orbit, I could go through and refresh this and get the new average or mean duration. Average and mean effectively mean the same thing. Average is the more common term, and then mean is the more statistical way of describing it, but they're both saying the same thing. Okay, last thing that I'm going to bring up, since we're here and we've seen it, let's see why there's a huge jump here. Okay, so just a moment ago we saw, I'm going to press play, I'm going to speed this up some, and we see we got contact, we zip around, that was one contact, here's the second contact, third contact, so we're on 3 contacts, 4, I'm going to speed this up even more, 5, 6, 7, and now I'm going to slow it down just a little bit, let's play again. We have 7 contacts, and now watch what happens when we come around. Oh, we didn't see this thing at all. Because we're slightly out of range now. Why do we end up with a large dark period? Well, here we are. We're at 5:43. If I go back to the previous one, we'll see the beginning of this happened at 1:35. So if I go backwards, let's play backwards. The last contact where we actually saw it was here. At about 1:35 in our scenario time. At about 1:43 was our last contact, and then we cut out. So, on this we go into what I would call a dark period. We can see here that this contact ended, looks like around 1:35, which is what we see here, at least looking at it, pretty close. And then we don't get contact again until the following day at about 1 a.m. So, here's why we have a dark period. Because now the orbit of the moon, the rotation of the moon, is taking this target away from our orbit. And we're going to have to wait a while for it to actually come back in. In fact, we go from January 5th all the way over to January 8th. So I misspoke. It's not 1 day. It's actually 3 days. And that's how long it's going to take for our moon to come back around where we're able to see it with our actual settings. So this is why we have a large dark period, a long period where we have no contact. Now, instead of having you look at each of those individually in this scenario, I've had it based around the mean duration instead. So, these are the key things that we wanted to take a look at. We've covered a lot in this particular lesson video, and they have many applications in a variety of scenarios as they get more and more complex. All right, until next time.